Good morning. In this session, I would like to discuss about synthetic curves. Synthetic curves are higher degree curves. Unlike analytic curves, they are simple second degree curves like x square plus y square is equal to r square, and x square by a square plus y square by b square is equal to 1, x square by a square minus y square by b square is equal to 1, and like that, they are simple second degree curves. Now, synthetic curves are higher degree curves because normally curves will be having C0 continuity, C1 continuity, and C2 continuity. That means C0 continuity is a position continuity. That means uh, a straight line will be having a C0 continuity, you can say. Y is equal to like that. A point, xy position is C0 continuity, and C1 continuity will be having both position and tangent. That means two curves are like here, so they are joining here. So here both will be having tangent, but this curve will be not having the curvature, different curves. Both the curves have different curvatures. So this is C1 continuity, and C2 continuity is two curves are there, and tangent is a point, and both the curves having the radius of curvature, same radius of curvature. So here two different radius of curvatures, and these 2 points will be having the infinite radius of curvature, and this like that. So that is how a curve should be having a C0 continuity, a C1 continuity, or C2 continuity. So normally, from cubic order onwards, we'll be having the curvature will be having C2 continuity. So the synthetic curves are the curves which are having higher degrees, like cubic polynomial, and second one is polynomial interpolation, and Bezier curve, B-spline curve. Cubic polynomial is a third degree curve. So like C0 plus C1x plus C2 x squared plus C4x cubed. This is a cubic polynomial, and depending upon the end conditions, we have to determine the constants of C0, C1, C2, C3. That is about cubic polynomial, and this cubic polynomial can be interpolated with the 2 points. 2 points, a cubic polynomial can be interpolated, and that is what we will discuss the cubic polynomial in separate video session. And the polynomial interpolation, there are having several points will be there, and we have to draw a curve passing through all the points. So for this, we have to use polynomial interpolation. And Bezier curve and B-spline curves are the curves which are used mainly in what you call wireframe models, like the car bodies and other features of like airfoil structures and ship hulls, and all these things require the beautiful controlled curves. That means these curves are higher degree curves, and they are beautifully controlled by the control points. So Bezier curve and B-spline curves are the curves which are controlled by the several control points. Like these control points are joined by straight lines, and these curves will be drawn between the first point and last point. Depending by varying these control points, you can adjust the shape of the curves. So Bezier curve, the degree of Bezier curve depends upon the control points of the given a given situation. And B-spline curve is something different. Here, the degree of curve will depend upon the control points and the knot points. That means Bezier curve will be having the highest degree, and the degree of the curve can be controlled from a minimum value to the maximum control points by B-spline curve. So here, apart from the controlling the control points in the B-spline curve, we are going to control the shape of the curve by knot points. That means like second degree, third degree, fourth degree, fifth degree, like that. So for example, a Bezier curve is having 6 degrees equation, and you can B-spline curve can be drawn between third degree to 6th degrees. So that by controlling control points, you can draw Bezier curve, and by controlling the knot points, you can control the degree of the curve and the shape of the curve. That's the beauty of B-spline curve. So basically, we are going to write a small minute-driven program of all discussion of all these curves. In this minute-driven program, we will be having two options. One is analytic curves, and second one is synthetic curves. So analytic curves, if you select, will be having a separate screen, a separate window will be open. In this analytical screen, we will be having several menus of line, circle, parabola, and like that, all the analytic curves options. And you can select the origin and the center of the point, for example, if you have set 2 points, 2 coordinates you can select, and you can draw a line. And in the circle, you select the center and draw a circle. Select center and radius, you draw a circle. If you select a center, you can draw draw a line by selecting median and max. Like that, options will be given, and menu-driven analytic curves you can draw. And similarly, you can select the synthetic option, and a separate window will be open. In this window, see the cubic polynomial and polynomial interpolation, Bezier curve and B-spline curves options will be given. So if you go to the cubic polynomial, it will ask to select 2 points and some tangent values, the input tangent, output tangent values will be asking, and you have to draw it will draw a curve between these 2 points. So cubic spline will be drawn. And if it is a polynomial, select several points, and you can draw a polynomial and join to all the points. And if you select a Bezier curve, it will ask to select the knot point, control points, and between these control points, a Bezier curve can be drawn. And if the B-spline points, it will ask the degree of the polynomial and number of control points, and you can draw a B-spline curve. So this is how in this synthetic curves we complete a small package of a small curve package for curves. You can say package for curves like that, and which will have a minute-driven and options like that. So in this further video session, in one video session we will discuss about the cubic polynomial. In one video session we will discuss the polynomial interpolation. In one video session we will discuss about Bezier curve, and in another video session we will discuss the B-spline curve. So that is what I would like to discuss in small video session. Thank you for watching the video.